This video will learn Newton's law. Newton's first law is the law of action and reaction. If A object exerts a force on B object, B object will exert an equal force on A object. When two objects interact with each other, there is a pair of action and reaction forces. This force's magnitude is same, but force direction is opposite. This rule means that force comes from the outside of the system. If don't have external forces, the motion of the system does not change. This is the Newton's first law. Newton's first law is the law of inertia. Objects maintain present state of motion. But if have external forces, the object is external force from external. The net force of object is no longer zero. At this time, there is Newton's second law. Newton's second law is the law of motion. Acceleration equal to net force divided to mass. Direction of acceleration is concluded by net force direction. Magnitude of acceleration is concluded by net force and massive magnitude. Acceleration and net force is proportionality. Acceleration and mass is inverse. Okay, for running of the Newton's equals, let's go solve the problem. We are in the elevator. Ft tension force, Fg gravity force, and mass. Question is, what's the value of the acceleration? Elevator acceleration. Tension force direction is upward and magnitude 7,800 Newton. Gravity force direction is downward and magnitude 9,800 Newton. There is no other force except these forces, so that net force is 2,000 Newton downward. Mass is 1,000 kg. By the Newton's second law, acceleration is 2 meters per second squared downward. Let's go another problem. Box is on the slope. Fn normal force, Fg gravity force, and mass theta is sloping angle. Question is, what's the value of the acceleration? What's the value of the box's acceleration? Depending on the coordinate system, solution is different. If we select the particular coordinate system, horizon axis is parallel to the inclined surface. Vertical axis is perpendicular to the inclined surface. Separate Fg into perpendicular Fg and parallel Fg. Fg is mg, downward. Magnitude is mg, direction is downward. And then perpendicular Fg is mg cosine theta, and direction perpendicular. Parallel Fg is mg sine theta, direction is parallel. Normal force magnitude equal to perpendicular gravity force magnitude, but this force's direction is opposite, so perpendicular net force of the box is 0, because the box don't move up and down. Parallel net force is parallel Fg. Therefore, net force magnitude of the box is mg sine theta. Direction is parallel in the particular coordinate system. By the Newton's second law, acceleration's magnitude is g sine theta. If we select the xy coordinate system, this is Cartesian coordinate system, horizon axis is x-axis, vertical axis is y-axis. Separate Fg into Fg x-axis and FG y-axis. FG's magnitude is mg. Direction vector is x value is 0, y's value is -1. This is unit vector. If translate FGY vector to origin, FGY unit vector is minus sine theta minus cosine theta. FGY magnitude is mg cosine theta. We can get the magnitude by FG dot product FGY unit vector. It is the same process. Translate FGX vector to origin. FGX direction is cosine theta and minus sine theta. FGX magnitude is mg sine theta. Normal force magnitude equal to gravity force y-axis magnitude. Net force y-axis of the box is 0. Net force x-axis is FGX axis. Therefore, net force magnitude of the box is mg sine theta. Direction is cosine theta minus sine theta in the xy coordinate system. By the Newton's second law, acceleration's magnitude is g sine theta.